Hair Anatomy Part 2. How hair is made of. In the organization of a single hair fiber, 3 alpha helices are twisted together to form a protofibril. This is the first fibril structure of the hair. 9 protofibrils are then bundled around 2 or more to form an 11-stranded structure known as microfibril. These microfibrils are embedded in an unorganized protein matrix of high sulfur content. Hundreds of microfibrils are connected into an irregular fibrous bundle called a macrofibril. These macrofibrils are grouped together to form the cortex layer of the hair fiber. Packed dead cells surround these structures and are known as the cuticle layers of the hair. In the center of these structures lies the medullary canal. Amino acids, the building blocks of protein, are made up of COHNS elements: carbon, oxygen, hydrogen, nitrogen and sulfur. The percentage of COHNS elements in hair is as follows. Bonds. Bonds in your hair determine its texture and shape and give each hair around a third of its overall strength. There are 3 types of bond that link the protein chains together. Disulfide bonds, which are strong. Hydrogen bonds and salt bonds, which are weaker. Side bonds such as hydrogen bonds, salt bonds and disulfide bonds link together these polypeptide chains. Alpha helix structure. The alpha helix is the descriptive term given to the polypeptide chain that forms the keratin protein or human hair. It is a coiled structure where the amino acids link together to form the coil. There are approximately 3 to 6 amino acids per turn of the helix coil. Each amino acid is connected together by a peptide bond. The peptide bond is located between the carbon atom of one of the amino acid extending bond with the nitrogen atom of the next amino acid. The cystine bond. The cystine bond, also known as the disulfide bond, sulfur bond, or just the S bond, is formed by cross-links between the cystine amino acid of the main polypeptide chain. This bond is perpendicular to the axis of the hair and between the polypeptide chains. Cystine is rich with sulfur, which plays a crucial role in bond formation. It is produced by the keratinocytes. These cells are located in the bottom of the dermapapilla, DP. Due to its position in the hair, it is responsible for the hair's strength or abrasion resistance. It actually holds hair fibers together. These cross-links are frequent in the hair fiber, with a maximum of frequency of 1 cystine bond every 4 turns of the alpha helix. It is this bond that holds your hair together and gives rise to the hair's overall strength, accounting for up to 90% of the strength. It is essential to break this bond in order to change your hair's appearance. Whether you are adding or removing color, perming or straightening your hair, this bond must be broken. Unfortunately, not replacing this bond will account for your hair feeling dry and damaged. The hydrogen bond. Hydrogen bond is an electromagnetic attractive interaction between polar, charged molecules, in which hydrogen is bound to a highly electronegative atom, such as nitrogen, or oxygen, which is readily available in keratin protein. This bond is located between the coils of the alpha helix and is responsible for the ability of the hair to be stretched and return to its original shape. It gives hair its elasticity. The hydrogen bond is electrolytically controlled and are the most readily broken down and most readily reformed. They are responsible for up to 30% of the strength and up to 50% of its elasticity. Hydrogen bonds are easily broken with the addition of heat. In the case of water, which accounts for up to 12 to 15% of your hair and as much as 35% by weight, becomes steam when heat is applied, making this hydrogen bond very weak. It is essential to reform this bond after using hot tools on your hair. The salt bond. Salt bond is an ionic bond. Ionic bonds involve electrostatic attraction between oppositely charged ions. These ions represent atoms that have not lost 1 or more electrons, known as cations, and atoms that have gained 1 or more electrons, known as anions. In hair, it is electrolytically controlled bond formed by the electron transfer from the side chain of a basic amino group, an amino acid with OH group, to the side chain of an acidic amino acid. This occurs in a position parallel to the axis line of the rotation of the helix in the hair. It represents a small amount of your hair's strength and elasticity. With an increased pH above 5.5 applied to your hair will instantaneously break the salt bond in your hair. Hair color pigment. Melanin. Melanin is a natural pigment that determines the color of your hair. When the production of this pigment slows down, hair turns gray or white. Your hair color is determined by the type and amount of melanin in your hair. Genetics play a huge role in which type of melanin you are born with. Melanin plays another crucial biological role in hair. It protects hair against sun rays, photoprotection, and ultraviolet (UV) radiance. Different amounts of these two types of melanin also determine hair color, as shown in the picture. When we are doing hair color, we are changing the melanin pigment.